Good morning, everyone, and welcome to our Shape Your Future session for today, our last one for term one, but we have plenty more planned for next term, so I will give you some more information about that at the end of the session. But firstly, as we gather from our various places around Australia, I would like to acknowledge the traditional custodians of the lands on which we meet. I am joining you today from Ngunnawal and Ngambri land, which is in Canberra, and I pay respect to elders past and present, and to any Aboriginal and Torres Strait Islander people who are joining us online today. And we acknowledge the knowledge forever embedded in custodianship of country. So today we have a fantastic researcher, Professor Qilin Wang, who is going to talk to us about his carbon zero sewage, and also about his journey through STEM. So if you have any questions at any time during the session today, you can put it in the Q&A function, not the chat one. So there's a chat and a Q&A. Put it in the Q&A. We will get to it at our Q&A section at the end of the talk. And please let us know anything that comes to mind. No questions are silly questions here today. And please listen to our speaker. And at the end, you'll be sent a survey to give us feedback on the sessions. And we use those to help us shape for future sessions and to know what we're doing well and what we're not doing well. So please fill them out. You should also, after the session, receive a worksheet which will have extended exercises around Qilin's work in the sector. So let's get into the session today, and I'd like to introduce Professor Wang.
Hi everyone. So thanks for the invitation and the introduction. So it's my great pleasure to have this opportunity to share my career journey and also my research with you. So my name is Qilin Wang. I'm currently a professor at University of Technology, Sydney. So maybe let me first share my slide. So from the slide, you can see that today I will talk something related to sewage, wastewater. So something actually dirty, but something useful. So in today's talk, so I will first briefly talk about my research that will focus on energy recovery from the sewage or from the pool. And then I will briefly talk about my career journey. And then finally, I will just give you some brief suggestions for the future researchers in STEM. So first, briefly regarding myself, I am currently working at the University of Technology, Sydney. So my research is related to water and wastewater treatment. So my early career achievements including some Australian Research Council fellowship and also Eureka Prize and Young Top Poppy. So regarding my research, so just as mentioned, my work is related to water and wastewater treatment. So just for instance, every day, for instance, when you flush the toilet or when you take a shower or when you do the dishwashing and also run a washing machine, actually you will all produce wastewater. So generally speaking, one person can produce around 150 to 400 liter wastewater per day. It depends on different, this will be different in different countries and different regions. And then this wastewater actually not only contains water, but also contains some organics, for instance, carbon, protein, this type of organics. And also it contains plenty of nutrients such as ammonia, phosphorus, etc. For instance, when we do the dishwashing, maybe there will be some food. The food maybe will go into the wastewater because the food actually is a type of organics or carbon or protein. So that's why actually in the wastewater, we will contain some organics or carbon. And also, for instance, when we flush the toilet, actually, the wastewater can also get some organics or carbon. And also, in addition to organics, for instance, the food also contains nutrients. For instance, the food contains protein, just like meat, it contains protein. The protein contains some nutrients such as ammonia, phosphorus, And also when we do the dishwashing, the detergent we use, sometimes it contains some nutrients such as phosphorus. So this type of organics, phosphorus and ammonia, and also this type of nutrients will all in the wastewater. And then when we produce this type of wastewater, then this wastewater will be discharged into the sewer pipe from our house. Then it will first go to the sewer pipe, and then this wastewater will go to the wastewater treatment plant. So in the wastewater treatment plants, just as mentioned, because the wastewater contains organics, so in the wastewater treatment plants, actually, we need to remove these organics or remove these nutrients. During this process, actually, it requires energy. So basically speaking, the wastewater treatment process actually is energy intensive. It will account for around 10% of municipal energy consumption. For instance, when we try to remove the organics or the carbon in the wastewater, generally speaking, we can supply aeration to get these organics oxidized. Because when we supply aeration, so actually we need energy. So that's why actually the wastewater treatment process is energy intensive. And also in the wastewater treatment plant, we have pumping, all these type of things. This will all contain energy. So this is about the energy consumption. And also, in addition to consuming energy, actually the wastewater treatment process will also generate greenhouse gas emissions. For instance, carbon dioxide, nitrous oxide, etc. The reason for that is that, for instance, just as mentioned, we need energy for wastewater treatment. But this energy, generally speaking, comes from the fossil fuels. But for the fossil fuels, actually, when we burn these fossil fuels to generate energy, actually, it will generate the greenhouse gas emissions such as carbon dioxide, etc. That's why actually the wastewater treatment process also generates greenhouse gas emissions. So generally speaking, the wastewater treatment plants can account for around 3% of the global greenhouse gas emissions. So in addition to consuming energy and also generating greenhouse gas emissions, the wastewater treatment actually also generates lots of waste. For instance, in the wastewater treatment plants, when we get the wastewater, after we treat the wastewater, actually we will also produce some waste. And then this waste need to be disposed of in the wastewater treatment plants. So in summary, the wastewater treatment process actually is energy intensive, and it's also generate greenhouse gas emissions, and also it generate waste. So what I did actually, I developed a technology try to recover the energy from the wastewater treatment plants. Basically speaking, is just as mentioned, in the wastewater treatment plants, actually we need to supply aeration to get organics in wastewater oxidized. But actually the organics in wastewater actually contains large amounts of chemical energy. So therefore, for the current wastewater treatment plants, when we use the aeration to remove these organics, actually we also destroyed the energy in the organics. So this is actually undesirable. What I did is that I have developed a technology actually can maximize the energy recovery from the wastewater. That means that I can recover the energy from the organics in wastewater, for instance, from the food or from the pool or this type of things. This because it contains energy. So what I did is that I recover this energy from these organics in wastewater. So my results demonstrate that this technology actually can increase the energy recovery from the wastewater or from the organics in wastewater by a few times compared to what is currently achievable. So the technology I use actually is only relying on a byproduct of the wastewater treatment. Therefore, this is green technology. That means that the technology I use actually does not require external chemical input or energy input because it only requires on a byproduct of wastewater treatment. So Therefore, this technology is a green technology. So here I briefly show some benefits of this technology. For instance, it can reduce the waste from the wastewater treatment plants, and also it can generate more energy from the wastewater, and also it can enhance the pathogen removal. So for this technology, actually, it has a positive impact on the society and the environment. For instance, it can reduce the greenhouse gas emissions. The reduced greenhouse gas emission actually is equivalent to taking around 150 to 200,000 cars off the road. It can also enhance the energy recovery from the wastewater by around a few times compared to what is currently achievable. So this energy recovered actually can fully support the energy required for the wastewater treatment plant. So if we apply this technology in Australia, actually, in all the wastewater in Australia, actually this energy generated can power around 70,000 to 90,000 homes. In summary, actually, this technology actually can transform the current wastewater treatment plant from the large energy consumers into the carbon neutral energy generators by maximizing energy recovery from sewage. So this is basically my brief introduction about my work on the energy recovery from the wastewater treatment plants to achieve carbon neutral wastewater treatment. In addition to that research, then I briefly talk about my early career journey in STEM. I was born in China, and also I did my middle school and high school in China. When I was in middle and high school, actually I spent some time in the beach and also in hiking, because actually my hometown is next to the sea. At that time, actually I was very passionate about the natural environment. So for instance, I was curious about the plants and the animals, for instance, how they grow on the planet. Actually, this is my initial seed for me to do the research. And also during that time, I started learning chemistry, physics, mathematics, biology, etc. Then after I finished my high school, actually, I continued to do my undergraduate and postgraduate study. At that time, I chose environmental engineering as my major. Specifically, actually, my study is related to water and wastewater treatment. Actually, that's the starting point when I started learning something about water and wastewater, because I love rivers, sea, or this type of natural environment. That's why actually I chose this major. Basically speaking, this major is trying to understand the water supply systems. For instance, the clean water supply. That means that when we're at home, how we can get the clean water from the tap. That is about clean water supply. And also the wastewater treatment. For instance, at home, when we produce wastewater, how we can get this wastewater treated to the clean water, relatively clean water. This is about my undergraduate and postgraduate study. And then after that, actually, I did my PhD at the University of Queensland at the Advanced Water Management Center. From the name of this center, you can see my PhD actually is also related to water and wastewater treatment. It's about energy recovery, wastewater treatment, and waste reduction. After I finished PhD, actually, I thought about my career again, because after I finish my PhD, I can continue to do the research in the university, or I can find a job in the company, because I'm very interested in research. So I decided to continue to work in the university. Then I found a job as a postdoc research fellow at the University of Queensland, and then continue to do this research. When I was at the University of Queensland, actually my job is a contract job and it's a research focused. Then when I work at the University of Queensland for around 2 years, at that time, actually, I want to find a stable job because my job at the University of Queensland is a contract job. So I try to find a stable job in Australia. Then I found a job as a lecturer at Griffith University in 2017. So I moved to Griffith University. At Griffith University, my job duties actually is different from my job at the University of Queensland. Because when I was at University of Queensland, when I was a postdoc research fellow, actually my job is mainly on research. It's research focused. But when I was at Griffith University, because it's an academic position, so my job also includes teaching engagement in addition to research. So it's so this is my job at Griffith University. Then after 1 year, actually, I found another opportunity at the University of Technology, Sydney. So I moved to Sydney, and then as a senior lecturer at the University of Technology, Sydney. Then I got promoted to associate professor and a professor there. That's what I am now. At the University of Technology, Sydney, my job is still related to teaching, research, and also engagement. So regarding my academic life, for instance, for the time being, for instance, I need to do teaching. That means that I need to deliver some courses, for instance, water-related courses and engineering courses to the undergraduate and the postgraduate students. I really like this type of teaching experience because you can always interact with young students. So you can always feel that you are young, and also you can always learn from each other during this process. So in addition to delivering courses to the students, I also supervise undergraduate and postgraduate students for thesis. For instance, when they are in their final year, so they can, generally speaking, they need to choose a topic, or they choose something they are interested, or I can give them a topic, so we can work together to form to make the student form a thesis. That's what I did in here. So this is about teaching. So in terms of research, so sometimes I need to do experiment to get some new experimental findings. When I get the new experimental results, so sometimes I need to write a research paper to share my results with the other researchers. And I also need to supervise PhD students to train the next generation of the young researchers. Because research needs money, so I also need to apply for fundings for grants every year. This is about my research. In terms of engagement, I also, for instance, in the university, you need to join the various committees, for instance, teaching and learning committee, research committee. You also need to for instance, sometimes as a committee to review the grant application or review the award application, or you also need to do some engagement with the external industry partners or something like that. That's about the engagement. That's basically my academic life look like. And also another thing I really like this type of academic life is that we can always travel around to attend conference, because you can travel around the world to attend the conference and to present your results to the other researchers. So during this process, you can also make new friends and learn new knowledge. So I really like this type of experience. Another thing I think is really great is that as a researcher, actually, you have freedom, because you can do whatever you want to do as long as it's related to your research. So you can make your own decision. That's what I really like about this academic life. Then I will briefly talk about some suggestions for future researchers in STEM. First, I think you need to explore your interest For instance, when you are at high school or middle school, you need to learn many subjects, for instance, chemistry, physics, etc. Although you need to learn every subject well, I think you also need to pick up subjects that you are most interested in it and then devote into it. For instance, this is also related to the research. For instance, if you want to do research in the future, definitely you need to pick up your interest, because the research can be very boring if you are not interested in it. But if that topic is really what you like, then the research can be very fascinating. Another thing is that you need to prepare yourself for your goal. For instance, you can set up your goal. And during this process, actually, if you have spare time, you can attend some research programs, and also you can do some self-driven activities. For instance, if you have spare time, you can try to reach out to the university staff to learn something new, not only related to your current study, but something new. During this process, actually, you can learn new knowledge, and also it can also enhance your CV. So that means that you are self-driven students. And also, you need to be patient and stay positive, because sometimes success, you can only achieve success after a few times failures. For instance, when you do the experiment or when you do the research, generally speaking, sometimes the experiment can fail 10 times before it succeeds. So you need to be patient and stay positive, because good things always take time. And finally, can enjoy your life, or for instance, have some good friends and hobbies, because this can power you. So this is basically about my talk. So thanks again for the invitation. And if you have any questions, so I'm very happy to discuss with you. Thank you.
That was really, really great to kind of see, yeah, as you say, all of that wastewater that goes out of our houses. I didn't even think it'd be 150 to 400 litres a day. That's huge amount. So just a little kind of a quick question about that is there, you said, you know, your research is helping these treatment plants become carbon neutral. Is there a point at which you think, yeah, they may be actually carbon negative, so they may actually help to reduce carbon in other areas as well? Is it possible, or is it?
Yeah, thanks for the question. I think definitely it's possible, but it depends on the development of the technology. I think, for instance, if you can continue to work in this field and then optimize the technology, I think definitely that will be the future of the wastewater treatment plants, can generate energy and also can be carbon negative.
Yeah. And so is your innovation in a scaled working treatment plant yet, or are you still in the kind of development stages for it?
For this one, this technology actually has already been patented, and also it's being commercialization for the time being. For the time being, actually, all the experimental work has already been finished, but currently it's being tested in the full-scale wastewater treatment plants.
Oh, that's great.
Yeah.
So you did come from China, and you went into the University of Queensland, into Griffith, and then to UTS. Is there a reason why you chose to come into Australia, particularly into UQ, to do your PhD and the rest of your work?
Because honestly speaking, why I was in the university, because my major is related to water and wastewater treatment, and at that time actually I read plenty of papers published by UQ, by my actually supervisor at UQ. So I am really interested in that topic. That's why actually at that time I contact my supervisor to see whether I can go to UQ to do a PhD student there. That's how I went to UQ at that time.
Fangirled your supervisor. This is great.
Yeah.
So is there anywhere in Australia where we're we're doing this sort of treatment stuff really well, or are we a little bit behind, say, other places in the world, or is somewhere else doing it better than us at the moment?
I think Australia is already doing pretty well in this field. For instance, in the wastewater treatment field, and there are plenty of top experts in the world. Top experts in Australia, actually, in terms of wastewater treatment. But definitely, there are some area maybe Australia is a little bit lag behind. For instance, in the wastewater treatment plants, they can do nitrogen removal. For one type of nitrogen removal process, actually, because maybe no need to talk about in details, just one type of nitrogen removal process, Australia maybe a little bit lag behind. But in general, actually, Australia is already doing pretty good in terms of this field. Yeah.
So what other countries, well, people in other countries do you collaborate with? Is it, is your team here, or do you work with other countries to kind of see what they're doing and apply it here?
Yeah, actually, I have plenty of collaborators when I do in research. For instance, Netherlands and also Germany, and because I also got funding from Germany as a fellowship, so because I need to go to Germany to collaborate with them. For instance, some European countries and also US, and also my home country, China, and also some Singapore. Yeah, this type of countries. Yeah.
That's great. We can actually now go and do the collaboration, which we haven't been able to.
Yeah, but collaboration sometimes previously before COVID, so you can, if you have time, you can go to their countries, or you can to have some face-to-face discussion or attend the conference. But now, because it's very difficult to go abroad, but you can still do collaboration, for instance, through internet or through paper publications, through discussions. So that's also a type of collaboration, but also actually it's not as good as the face-to-face discussion. Yeah.
Oh yeah, face-to-face is pretty good. So yeah. You did mention research papers, and they're very much the reason why you learn how to write reports and science reports at school. Yeah. But how many of these papers would you write and publish in a year, for example?
For instance, it depends actually. For instance, because currently my major task is supervising PhD students. So actually the PhD student will write the papers, then I will just revise the papers or give some suggestions. So basically speaking, currently maybe I only write maybe one paper per year, because I need to, but I need to revise plenty of papers. But before I was when I was a PhD student, or when I was a postdoc, when I need to do plenty of experiments, generally speaking, I publish maybe 2 to 5 papers per year as a first author. Yeah, that's my.
This is a lot of experience, a lot of writing in the year. So you need your English as well as your science.
Yeah.
So you said you really early on you snuck in that you won a Eureka Prize, which is the Oscars of science. What did it feel like to win that Eureka Prize, and what sort of happened after you became a winner?
Actually, when I won that prize, actually I was quite happy, because actually just in my category, actually I'm the first person actually who won that Eureka Prize in my field, in the wastewater treatment field, as an outstanding early career researcher. At that time, I was very happy, and also after I got Eureka Prize, I think I also got plenty of opportunities, because this is very prestigious prize. So some researchers or some industry partners actually approach me to for instance, for the potential collaborations, and that's pretty good. And also another thing is that because it can also enhance my CV. So for instance, I can also apply for something else. And also it also built my confidence, because it's a very prestigious award. So I think by winning that prestigious award, I think, oh, I'm doing pretty well. So I can build my confidence to generate more positive results in the future.
Yeah, especially an early career research award is really good. You know, usually gotta wait years for that, so it's been good. You You did mention that also when you were quite younger, you liked going to the beach and hiking and things like that. Do you still get to do that occasionally between all of the fantastic stuff you're doing as a lecturer?
For the time being, actually, I did not do that so often because maybe I become a little bit lazy for the time being. Yeah. So sometimes hiking, maybe not, but beach sometimes I will go there because I live in Queensland for many years. Just maybe 3 or 4 years ago, maybe 3 years ago, I moved to Sydney. So, but sometimes I still go back to Queensland, to Queensland. Then during that time, for instance, I went to Gold Coast. So sometimes like this.
Yeah. Beaches.
Yeah.
So is there anything that you do when you're not doing science, something that's kind of a bit separate from your work?
For the time being, actually, I spent lots of time in the office and also in my work. Just maybe sometimes I just watch some videos or something like that. Yeah,
that's switch off.
Yeah.
So at school, what was your best subject? What was the subject you really kind of enjoyed, and what was one you were like, oh, I wish I never have to do this again?
Actually, when I was in the school, actually, my favorite subject actually is mathematics and chemistry, and also biology. This something like that. Actually, this is also related to my current research. For instance, my current wastewater treatment actually is a biological treatment process, so it needs knowledge regarding the biology, and also it needs some chemistry knowledge. So that's that's how I combine my previous interest with my current research. But for some subject, for instance, sometimes history, geology, this type of subject, I'm not very good at it because sometimes you need to, for instance, when you do the examination, sometimes you need to memorize lots of things about this. So that's why actually I did not like that type of subject very much. But when I was in high school, actually, you can just in the first year you need to learn all of these subjects. But after during the second year or third year, you can choose which subject you can learn. For instance, you can choose chemistry, mathematics, physics as your major subject, or you can choose, for instance, history, geography, for instance, as your major subject. Yeah.
It's my thing either.
Yeah.
So I'm really keen to see, you've got a lot of kind of PhD students and students that you're supervising. What are you seeing is the next generation of the next level of the research that you're doing, that they're building on, that we could see come out into being commercial in the future?
Sorry, can you repeat?
So what's kind of the next, after your research, what are your kind of PhD students seeing as the next generation of your research? Where can it go, I guess?
I think, for instance, for the PhD students, actually, currently they are still doing something related to my research, but I also encourage them to do something new. For instance, to connect my current research with some new research. In that case, we can also do something new. And also after, for instance, they graduate, actually, they can also choose a career, for instance, in the university or in the company, something like that. Yeah.
So I've asked all of most of our speakers this year, if you weren't doing what you were doing, was there a fork in the road that you might have been something else, that you might have chosen a different career or a different path of research that's different to what you're doing now? Is there a chance you would have been something else?
This one, actually, I never think about that.
Yeah, it's good if it's like, look, got it, and all your goals are, I mean, your path was quite great, and as you say, quite early on, it was the water and the rivers, and you're seeing an output now. But sometimes people are like, oh, there was a chance I could have been, a lawyer or a vet or something. Like, why did you choose what you chose?
Yeah, actually, when Previously, I thought maybe I want to be a doctor actually, initially, but then, yeah, but I did not think about that too much. But then I chose this area. Yeah.
No, I mean, it's great in the environmental sense when we're looking at carbon neutral and trying to, reuse all of our waste. I was going to ask a very terrible question, which was, is there something that makes good organic inputs? What's a good input into the system?
Oh, it's
or bad? What ruins the whole system?
For instance, because for the domestic wastewater, that means the wastewater we generate every day. For instance, the good thing actually is rich in carbon. For instance, some food, for instance, but this is not good because it's a type of waste. For instance, when you eat something, if you haven't finished your food, sometimes you will throw them away if there is some remaining food. And then this food actually is rich in carbon, in organics, so it can be a very good source to generate the energy. And also, for instance, the very dirty things, for instance, pool, this type of things, it can also generate energy. Anything actually it contains organics or protein or this type of things actually can be a very good source to generate carbon actually. And also, in addition to generating carbons, in addition to generating energies from these carbons, actually these carbons can also be used for nutrients removal, for instance, for nitrogen removal or from phosphorus removal. So actually this type of carbon is very, very useful in the wastewater treatment plants. So it can do lots of things, can be used for energy recovery, can be used for nitrogen removal, or it can be used for phosphorus removal. If you do not have enough carbon in the wastewater treatment plants, sometimes you need to add external carbon into it. For instance, some wastewater treatment plants add ethanol or methanol into the wastewater treatment plant to supply enough carbon for their treatment.
So we've got to make sure we eat all of our vegetables, get all of that carbon, all the poo that we need to do, and we get all that carbon into the system, which is what we need. It's just really lovely to see a system that's using what we already do and waste we already produce to try and stop getting more carbon dioxide into the atmosphere, and also to try and make us a little bit more environmentally friendly and keep those waterways a lot cleaner than we had been doing in the past. So thank you so much for joining us, and thank you all for joining us online as well for our Shape Your Future series this term. And look out for the survey to give us some feedback on our talk today, and also for the worksheet on Qilin's work. We will have a whole set of new researchers speaking next term. You can find all of those talks on the STELR website, stellar.org.au, and keep watching all of our socials and you'll get an email. But thank you, Qilin, for joining us today.
Thank you. Thank you very much for the invitation. Nice to be here. Thank you.